Okay, sorry again, I had to change the battery. I was talking about the conduction losses in diodes. You guys remember that we modeled the diode when it's conducting using forward bias voltage and a resistor. Both of these have some losses. The losses in this one, we need to calculate the RMS value of the diode. And for this one, it's just like, because this is a DC voltage, to calculate the power, like we only need the DC value of it. So we have the RMS value, the DC value of ID. We also calculated this before. It's 1 minus D times ILAC RMS. Again, if you don't know how to calculate this, we did this in previous videos. ILRMS, it's, sorry, this should be ILRMS. ILRMS, that's my bad, ILRMS, not AC, this is IL. So we showed how to calculate this, ILRMS. It's the square root of ILDC squared plus ILAC RMS squared. This one for boost converter was IO, for buck converter was IO divided by 1 minus D. For both of buck and boost, this was delta IL divided by 2 root 3, right? So you can calculate this, replace it here, calculate ID RMS and ID DC, right? Then the conduction losses of diode, let me write down P sub D losses. It has two parts. One part, it's gonna be, because of the forward bias, it's gonna be VFD times IDDC. Because this is a DC voltage, only the DC value like causes a loss here, right? So that's why we have the DC value here, plus this part, right? So this part RD multiplied by ID RMS squared. So this is the conduction losses for diode, right? Again, this is a general formula. It's valid for buck converter or boost converter. So just like these values will be different. Like here, like as I mentioned, like this value for buck and boost, it's going to be different. So it makes like everything different, but the same formula. Okay. Last but not the least, for conduction losses, for inductor, we mentioned that we have an inductor, like we also have an internal resistance for an inductor. Let's call it RL. So P of L conduction losses, it's gonna be RL times IL RMS squared. Okay, for capacitor, first of all, let me take a look at the IC RMS for capacitors. For both cases, IC RMS is actually root D of IL RMS, and P of C conduction, P sub C conduction losses is equal to RC multiplied by I sub C RMS squared, right? So this is the conduction losses in inductor and capacitor. So we finished all the conduction losses that happens in both boost converter and buck converter. Again, these conduction losses is when the switches is basically closed. We're not talking about the losses that happens when you turn something on or turn something off, like when the diode or the transistor turn on or off. This is like when everything is just like basically not changing, and this is like the conduction losses, right? So this is the first thing that we had to do. This part is done. Now let's go to the switching losses. Okay, so the switching losses, it's gonna be a little bit more challenging, but let's just see how we can do this. And maybe pause this.